So hi guys, so today we will be looking at the second part of the TensorFlow production pipeline project that we were doing. And as I told you in the previous video that we would be looking at the MLMT database this time. So we would be starting from the exact point where we left. We talked about the pusher component, and now we would be entering the MLMT database. So what is actually MLMT database? The whole full form. So it is a machine learning metadata database. You can see something like this from the official website. I would just give you the link to this in the collab as well and in the description section. So it is a library and that is used for recording the metadata so that the data scientists or the machine learning engineers which have been working on the production pipeline can actually look at the components and the information that is associated with that pipeline. And this is a library which is an integral part of the TensorFlow extended, that is TFX. But the Google guys have designed it in such a way that you can even use this independently without using even the TFX part, but usually it's used with that only. So as you can see, there are three types of metadata. The first is about the pipeline and lineage information associated with the pipeline components. The second is the about artifacts that were generated during the pipeline run, and the third is about the executions of the pipeline. So a typical production pipeline serves multiple models as new data arrives. So when we encounter uh, abnormal results in served models, we can query the MLMD database to associate the erroneous models. So we can trace the lineage of the pipeline components that correspond to this model. So we would first set up the MLMD store with the interactive context that we have defined previously. So we would do the same things. We would just call that interactive context, and we will call the metadata connection configuration. So we have called that, and we would put all TFX artifacts that are stored in the base directory. So we would just run this, and yeah. Now we will create some helper functions to view the data from the metadata store. So this would be a display type. So this would be a helper function to render data frames for the artifacts and execution type. We would just call all the table types, all the types that are already available, and we will just display the artifacts, and we would just run this and the display properties. So what we are doing, we are displaying the types, the artifacts, and the display properties. So after running, we would just see these three things in our visualization of the ML metadata. So I would just run this, and yeah, here you go. So I would just put that in a different view. Yeah, so you can see this is that index, the ID, and the name, the examples that we took, that the example statistic, the schema, the example anomaly, the model run, everything that we did from in the pipeline from the very starting, the all the artifacts that were stored from the very beginning. You must be remembering, remember example statical, schema gen, example gen, statical gen, the pusher component, the model blessing, the model evaluation component. All the things have been defined here. So the next thing that we will move to is querying all the pushed model artifacts. So you see here the pushed model, the store.get artifacts by type, the pushed model that we have already defined, and we will display the artifacts. So I would just run this, and yeah, here you go. So this is the index, the artifacts ID, the type, and the URI of the same. Now we would be querying the metadata store for the latest push model. So this tutorial has only one push model, so we would be using that only. So this is the push model, and the display properties, the function that we have calling from above to display the properties. So this would be the property index, property, and value that we defined above. So you see the producer component, the push destination name. So this is basically the push model that you have already used in the pusher component. So it is displaying all the properties, that is producer component, push destination, name, pushed version, TFX version, everything that has been used there. So these are the values that you're getting. And one of the first steps in debugging a push model is to look at which train model is pushed and see which training data is used to train that model. So obviously, because if there is some inconsistency in that, you would be looking at the training data and the training model which was used here. So the machine learning metadata provides traversal APIs to walk through the provinces graph, which can be used to analyze the model provinces. I know this is a bit complex part, but don't worry. Once you start using the graph part and everything to actually debug the part, you would get familiar with it. So I would just run this. What is exactly happening in this? We are taking the store and artifacts to get a list of artifacts with one hope of the artifacts of the interest. you can see the execution IDs we are seeing that all the artifacts that were present in the total artifacts that we stored in the beginning, and we are just seeing the output of that particular prototype. So from there we are getting the sets and we are retrieving the data. So now we will be querying the parent artifact for the push model. So this is, we are calling the same function here and displaying the artifacts. So I would just use this. So this was the model and this was the model blessing. You can see the trainer, the evaluator, both are present here. So we get this. Now we would be querying the properties of this particular model. So I would be just calling this, and you see the parent artifact which we have defined here, the first part, which is model, the index 0, and we are displaying the properties of that. So yeah, this is it. So you can see here the property, the name, state, tfx version, the producer component, all the things are displayed here. Now similar thing can be done to the second thing, that is model placing. Now but whenever I do this thing here, one thing that you would notice once I run this, yeah, you would see a more number of properties here. That is because of the evaluator and the difference between the evaluator and the trainer part. The tfx version, the current model, the producer component, blessed, name, state, current model ID 5. So this is the difference that you are seeing between the model and the model blessing. So this is the trainer module 5, this is the evaluator blessing 6. So yeah, this is how things are working here. Now we would be looking at the exported model, the stored values that we have used here to upstream artifacts for the model, and similar things are happening here. This is the examples, the schema, and the model. So nothing very tough here. Once you have defined the functions, you just need to call it again and again to actually visualize the things. Now we would use the training data that we have used, the model parents one. So you must be thinking where this training data is coming from. So yeah, here you see this is the model, the name, property type which you are used here, that is the same thing which we are calling here, the model parent 0. So inside that you can see the split names, that is training and evaluation, the input fingerprint, the tfx version, the state, span, everything is present here, the payload format and everything. So now that we have we have the training data that the model trained with, we would just query the database again to find out the training step, to see the query md part. So we would just use the store.get execution types for that, and to get the registered execution types. So here I think the trainer part comes here. Yeah, this is the index, the trainer component, all the things are displayed here. We would be needing the trainer component, I guess. So the training step is the execution type named tfx dot components dot trainer. You can see here. So we would transfer the metadata store to get the trainer run that component to the pushed model. So we are defining the find producer execution function. I would just make things a bit easier here for you, and we would just run this. And once this has been run, I would just call another cell to make things a bit easy. Now we will find the trainer, and we would just call this find producer execution to get that particular part where the execution was done, and we are just calling the stored and the imported model, and inside that the store is same, and the display property which we need is trainer. You can see here this particular trainer. So I would just call this, and here we go. So this is the whole thing which is displayed here. You can see the property, the component ID, state ID, module file, the feature slicing specs, everything that was done in that particular state of trainer component has been displayed here. The module path, example splits, evaluation configuration, pipeline route, everything is displayed here. So as a data scientist or as a machine learning engineer, while debugging the model, seeing the exact place where anomaly is being occurring from a while, you can go here and validate the things and just correct the sequences. I would not say actually sequences, but the way it has been working. So yeah, this is it for the video. In the next video we would be talking about some pipeline part, more about cloud based, I would say Apache Spark or something like that, Kubeflow we can talk about. So you can just tell me in the comment section also that what exactly you want. I would just try my best to make a video on that regarding the same. So thank you for watching the video. Thank you and have a nice day.